So we've got an example to do with dynamics and inclined planes. So that means that things sliding on inclined planes. So we've got a particle hurled at rest on a rough plane which is inclined at an angle alpha, where tan alpha is 0.75. It seems a strange way of describing an angle, but we'll deal with that in a moment. Coefficient of friction between the particle and the plane is 0.5. The particle is released and slides down the plane. We're going to find the acceleration of the particle and the distance it slides in the first 2 seconds. Okay, so first of all, let's just talk about what's going on with this angle. So it might seem a bit of an odd thing to do, so rather than saying what the angle is, describing it in this way. Obviously, we could do inverse tan of 0.75, find what the angle is, but actually that's not really the best thing to do. What we're interested in is things like sine alpha and cos alpha, because that's what we use when we resolve forces. So we're going to calculate those rather than alpha itself. So to do that, we've got tan alpha is 0.75, well, that's really 3/4. So if we do a little diagram, a little triangle, alpha here, so tan alpha is 3/4, that's the opposite is 3 over the adjacent, which is 4. And then we can use Pythagoras to work out what the hypotenuse is, and what's 3, 4 and 5 for the hypotenuse there. And so we could write down that sine alpha is 3/5 opposite over the hypotenuse, and cos alpha is the adjacent over the hypotenuse, so 4/5. So they're going to come in handy later on. So now we're going to draw a diagram of the actual situation. So we've got the plane itself is going to be something like this angle of alpha. We've got some particle held at rest here. And then we've got the weight of the particle. And we're going to have various forces going here. We're going to get a reaction force. And we've got friction. So it's saying it's held at rest, but it's released. So it's as though someone was like holding it here and then letting go. The only force is actually acting here. Okay, we don't actually have the weight of the particle of this, so I'm just going to call that W, and then I'm going to split that into components. So this angle will be alpha, and then this will be W cos alpha, this will be W sine alpha, and from there we can resolve the forces parallel to the slope, so that involves F and W sine alpha, and perpendicular to the slope, which will be this way. Okay, so if we go parallel to the slope first, the W sine alpha is going to be making it accelerate down the slope, because that's actually what's going to go on. So we know W sine alpha minus F is equal to 0, equal to MA rather. So it doesn't equal 0 in this case because it's not in equilibrium. And if we resolve perpendicular to the slope, I'm going to get R take W cos alpha equal to 0. And it's equal to 0 because it's not accelerating perpendicular to the slope, it's not bouncing along or anything. So R is equal to W cos alpha, and because we've got cos alpha was 4/5 earlier, that's 4/5 W. Okay, and so bring that back. We've got R is 4/5 W, but we also were told in the question that the coefficient of friction is 0.5. So that's going to give me a way of working out what F is equal to. So F is going to be equal to 0.5 R. So that's equal to 2/5 W. I can substitute that into the equation up above. So we've got W sine alpha, so I'm substituting into this equation here, take F, which I've now got as 2/5 W, is equal to MA. It looks like we've got a lot of unknowns there, but the weight is equal to mg. So I'm going to say mg sine alpha, take 2/5 mg is equal to ma. And then I can cancel the m's out. And I've also got sine alpha from earlier. Sine alpha was 3/5, so I've got 3/5 g, take 2/5 g is equal to a. So in other words, a is 1/5 g. And we can actually calculate what that is as well. So that is 1.96 meters per second squared. Okay, so the other part of the question is to do with working out how far the particle slides in the first 2 seconds. So this is a kinematic equations question, in fact. So we've got the acceleration is 1.96 meters per second squared. We've got s is what we're trying to find. The time we're given is 2 seconds. We're given an initial velocity of 0 because it was held at rest. So the equation that connects those is s equals ut add half at squared. So I can just substitute into that. So that's going to be 0 plus a half times 1.96 times by 2 squared. And then we can calculate what that is. That's equal to 3.92 meters, and that's what we're looking for.